Okay, we're doing section 3.1, day 3, and that's the last part of our essential learnings that's on the sheet from yesterday. And we're going to learn the relationship between the graphs and the derivative. Now, you can't see that f prime very well, but it's there. So it's f prime. And then we're going to graph the derivative of, no, we're not going to graph derivative from data points. We're going to go the other way. We're going to graph the function given the derivative. Okay. Okay, you guys ready? And, yeah, okay. Okay, so you guys, this is the function right here. And I'm going to make this blue a little bit darker. Okay. And actually, you know what I'm going to do? In the last class, I graphed it over here, but I'm going to graph it on the original graph, maybe transfer it if I want. But now what I look for, this is my function. I want to find the derivative. And what is a derivative? It's just the slope of the tangent line. Well, there's some obvious things here. Noah? Right here, what's the slope up at the top here? 0. So, actually, looks like it's 1.5. So at 1.5, I'm going to put my 0. I guess I will put it over here. There's another place it looks like the slope is 0, which would be down here. Almost, not a little bit bigger than 4, but maybe 4.5 to 5. It looks like it's down at 0 here. I'm just estimating. I just want to get a picture of this. So now I'm going to work through this, and I could make a table of values. I didn't in the last class, but if you want me to, I will. Like right here, that looks like about a slope of 1. Okay? Well, if I go over 1, up 1, just looking at my slope, that's like it'd be a positive 1, wouldn't it? And that looks like that's at 1/2. So when x is equal to 1/2, the slope is approximately 1. So when x is 1/2, the slope is approximately 1. Now what happens when I get closer to 0? What's happening to my slope? It's getting bigger and bigger. Matter of fact, what about at 0? It's undefined. So that means I'd have like a vertical asymptote there. So it's positive. The slopes are positive till I get to this 0. And are we going to do that gradually? Yeah. So we're going to start up here, and it's just an estimate, and it's going to go to 0. Then, okay, girls, math. You know what? 2 hours of math, right? Because that would be 2 hours and you have to watch the video again. Okay, and then what happens here? What's true about the slope over on this side? Positive or negative? It's negative. Until I get here, it's getting more negative, but then it starts to increase again. Like here might be the slope is -1, but what about the slope here? Slope is -1/2. Okay, so where was that pretty steep? Looks like it's about 3. So at 3, it looks like it's at -1, but then coming into the 4, it looks like it's -1/2. So it might look something like this. And that's the derivative. So you can draw a picture of the derivative, which is a graph of the slopes on the y-axis and the x's on the right. It does look weird, doesn't it? Yeah, you're just estimating the slopes along the line. So if I gave you y equals x squared, so I'll try to get my axes in here. Okay, ready? If I gave you y equals x squared, we know what that looks like. Ugh, that wasn't very good, was it? Hang on. I'll just slide it over a little bit. That's better. What's true about the slope at the vertex? It's 0, right? And what's true about the slopes over here? They're negative. right? This looks like maybe -2, maybe -1, -1/2. So they're going to be down here. And what about the slopes here? It's going to be like 1/2 here, maybe 1, 2, it's getting bigger. So it looks like this. I can do that because I know what the derivative is. It's going to look like a straight line. Basically, you want to look for your zeros, and you want to look for the slopes are negative, which is on the left side here, and where the slopes are positive on the right side. So we could do that. We could graph a derivative on our graphing calculator. And the syntax is going to be, you know, the function is going to be n derived. Remember where that was? That's in Math 8. If you have an Inspire, you just type it in. Not sure that that works, but anyway. And you want to put your function in y1, and you want to do it with respect to x, because a derivative is how the y changes as you change the x values. And I want to do it for every x, not just a single one. So in the lab, you had a constant here. You had a. And we could check it that way. But before we do that, how about if we graph the sine function and see what its derivative looks like? We'll do it as far as. I want to do it with you, just so wait a minute. Okay, remember what the sine function looks like, right? No? Okay, that's the sine function. Nope, it's a 0. So here the slope is 0. I always find these first because they're easy, right? And what's true about the slope from this point to this point? Is it positive or negative? It's positive, right? It starts out small here, you know, like a half or something. And here in the middle, it's getting to be its steepest place. So the slope is the biggest number there, which looks like it's about 1. And then the slope is going to start getting smaller again. So it goes down to 0. And now what happens to my slope over here? It becomes what? Negative. Yeah, it's going to get steeper. So I'm going to go down to -1. But then what happens? This is -1/2. It's actually coming back up here like that. What graph is that supposed to look like? Yeah. So the derivative of the sine is the cosine. Well, let's use our calculators. Yes. Yes. You just estimate. What? A calculator or how to estimate? Just estimate. This is what? Looks like a slope of -1. Doesn't it? What happens to your slope here, though? That's not -1 anymore. That looks like it's -1/2. Make a table of values if you need to. I just estimate. No, we just moved the desk. Just the slope of the tangent line. Here it looks like +1/2. So here it's 0, and this is the slope of a +1/2. So it's there. And here it's the steepest. Looks like it's a slope of 1. I'm just connecting the dots. We'll see it graph. Because these were slopes of the blue curve. That's what's the slope there. It's 0. I always find the zeros first. So let's go back and do. Sorry. I have too much open. Okay, so let's go back and graph y equals. Let's clear that out. Remember the lab equation? Might as well start with that one. It was x cubed. Was it minus 6x, right? Plus 3? Plus 3. My window, I had from -4, I believe, to 3. And then on my y's, I had to get up to, I went -10 to 12, I believe. I had it set up in the last class, but it won't, it'll be, oh, we'll find out. okay. Okay, there's the graph that we did in the derivative lab. And now let's graph the derivative of this. And I'm sorry this is not in color, but here's how you do it. First off, I'm going to go over here, and I'm going to change this to be the circle trace. Remember how to do that? You press Enter, and you press Enter, so you get the little circle. I just like that because I can see it. Oh, should we do this simultaneously? We didn't do it simultaneously, but that would be kind of nice. Now I want the derivative of that because I don't remember how to find it. Now I'm in the classic print, so it's math. Do you remember what number it is? 8. Ooh, you guys are good. And now, how do you get y1? You go to vars. Everything is over to the right. I sometimes forget, but and then it's comma x, comma. Before we did it at a point. Now we're going to do it at x. Where's what? N derive is math 8. Oh. Then, if it comes up in pretty print, it's going to be d over d. And then it says x equals. I have it backwards, but that's okay. So here you put y1. Here you put x. And then you want to do it for all x. Yeah, it's off to the side or something. Yeah, we are. Yeah, it's where the boxes are. It's where the boxes are. You have to arrow over. Now, you probably can't do it. Doesn't look like you're in 83. Oh no, there it is. Oh, press enter.
Oh.
Press enter. Changes them.
I don't have like the.
You have to do N drive. You actually have to type in N drive.
I have that, but then I don't have the.
Then you type in Y1.
I type in like
Y1 comma X. And I don't know on 89 what the syntax is.
so like that.
I think that I may not want that other X, but we can try it. Yeah. Okay, we're going to do this simultaneously. And I can't, if I remember how to, X resolution will change the speed, but I don't exactly remember what it is. Okay. No argument error. Okay, so I'm going to go under mode, and I'm going to change this to simultaneous. So we'll graph the function and its derivative at the same time. Mm-hmm. Did you guys change it to simultaneous? Because it's kind of cool. You go to mode, and you arrow down. So if I press mode, sequential or simultaneous? Simultaneous is really cool. Okay, we ready? Graph. Okay, here's my function. There comes my derivative. Now, the derivative's got to hit 0 here because the slope is 0 at the top. And the slopes were all positive. Now the slopes are negative. See how they're going down? And it's going to end up hitting another 0 again when this bottoms out. There it is. Yeah. It does look like x squared, doesn't it? Well, you don't know what it is. That's using shortcuts. You could find, oh, you know what it is, actually, if you did it in the lab. Okay, so you want me to go back to y equals? Is that it? Okay. Should we do the sine function? Yeah. Should we do it simultaneously? So I'm going to clear out this one. And now make sure you are in radian mode. So press mode. Yeah, because in science you switch it to degrees. Okay, so I'm going to go to y equals, and I'm going to put the sine of x in there. Okay, ready? Okay, so here, oh, I'm going to stop that. I want to zoom it trig. Otherwise, it won't be fun to see. There we go. Now, look what happens here. The original function is the one without the circle. Now it's slowing down. I mean, you can't see it slowing down, but it's slowing down. It's going to come up to a stop at the top. The slope is 0. And I can, if I go to parametrics, I can actually show you the speed. Now, when you take your car from reverse into forward, what do you have to do before you do that? You have to stop. The slope is your speed. If you don't do that, you're going to get in trouble. That's interesting. I wonder if there's a connection. There's a lot of connections with nature and math, so I don't know. Okay, ready? Missing somebody in the front. Okay. Now, is that it? I think that was it on that one. Yep. Now, turn your page over. Now we are given some information, and that's not the right title, but we're given the derivative graph, and we're going to try to graph the function. And don't do what I did in my first class. I forgot to read everything. It says f of 0 is 0. The graph of f prime is this figure right here. And it says the function f is continuous. I forgot to read that part. Anyway, they have to tell you that. And so I want to try to draw f. That's what my goal is. Okay, so when I analyze this, remember now this is f prime, which is the slope. So they're saying that when x is smaller than 1, that's this part right here, x is less than 1, what's the slope equal to? Negative 1. Okay? It's always negative 1. So I can graph points. And on the other side, over here, when x is greater than 1, what's the slope? 3. Now this is the derivative. Remember, derivatives are limits. So the limit on the left side is negative 1. The limit on the right side is positive 3. Can you find the derivative at 1? No, that limit does not exist. Okay? So I can still draw the picture of this. So we'll go ahead and draw it. And it says f of 0 is 0. I'm hoping everybody can do that. I have to have an anchor point. And it says when I'm coming into that point, the slope is a constant negative 1. So it's over 1, up 1. Over 1, up 1. You see a slope of negative 1 here? It's always negative 1 on this line, isn't it? And it would go forever, but it doesn't. It stops at 1. It's not including 1, so I'll put an open circle there. Now what's the slope? Oh, but it did say, it does say, though, it's continuous. No, where does it say the slope is 0? This is the slope. This is 3. I'm not doing the slope, but this is not the function. This is the graph of the slopes. So the slope of my function is always going to be 3, and it has to connect. Well, that's on the right side. What's the slope over here? Sophie?
Negative 1.
Yeah. Yes. This is f prime. Yes.
Oh, I actually really get that.
It's kind of cool when you see it. Okay? Now, it's continuous, so guess what? I have to start here, but what's the slope of my curve now? And it's always 3. Over 1, up 3. 1, 2, 3. Yeah, this is all new. Now, is it continuous? It's close because it said it was continuous. It's continuous, but can you find the derivative at this point? No. It's not differentiable. That's the word. We have to know that word. Why is what? Because it said it was continuous. So I have to close it. But can I find the derivative here at 1? No. This would be your velocity. That would be your position. You're going the other way. You're not doing the derivative. You could do the slope of this. What's the slope of this one? It's always 0. Except at 1, because 1's not even in there. So it's a different way of thinking. But notice what happens. I get that sharp corner, and I can't find the derivative there. The derivative does not exist. Now, if you want to say it does exist, how could you possibly say it exists? Because on this side, it's 3. Remember, the slope is 3. That's the derivative. On this side, the slope is -1. They're not the same. Which one are you going to choose? That's the problem. That's the same as driving backwards and then shifting into drive without stopping the car. Very bad. You must always slow down until your velocity is 0, and then you can speed up, no matter what direction you have. Okay, ready for the next one. And then we're almost done, but then you'll have some questions. Now, this is a hard question because you've never seen one like this before. Show that this function has a left hand and a right hand derivative at 0, but no derivative at 0 itself. Should we draw the picture first? Because now I know how to do this on the graphing calculator, so we could do it there too, but we're going to just graph it right now by hand. And we can go to the graphing calculator if you want. But okay, so I have, when x is smaller than 0, I have y equals x squared. What if x is 0? What's f of 0? 0. I'm going to use this one, the first equation. Then, when x is 0, this value is 0, but I have a slope of 2. Now, that's a picture. That is not the algebraic solution. Can you find the derivative there? Well, let's go ahead and let's graph that. Now, what I really like graphing it is on the Inspire, but I suppose you want to do the other one, because the Inspire zooms in so nicely. You have to buy it on Schoology to get the best price. Otherwise, you can buy it on Amazon. But it's about like 30 Schoology, schoolsavers.com. I have to post it up there. Okay. Oh, I could do that. But I'm going to clear this out. And I'm going to turn this one, well, let's just clear it out. You could leave it there. Now, I don't want the circle trace either, so I'm going to turn that off. Back up to the regular one. Okay. So you guys know how to do this? We want to graph x squared. So it's x squared. And I want to graph it for x less than or equal to 1. So you need a parentheses. And then you go into test, which is right above math. Second test. Oh, I forgot to do that. Oops, I got to quit. I forgot something here. So y equals x squared. I want to say x is, I forgot the x. X is less than or equal to 1. So x, and then I have to go into second test, and that's where I get the less than or equal to, which is 6 to 1. Was it 0? Oh, you're right. I was thinking of the other one. 0. It's under second test. We have to do the other one. So it's 2x. So you go 2x parentheses. I want x greater than 0. X. Okay, where do I find it? I find it in test. I had to remember that. Second test. X greater than. So it's 3 then 0. And I prefer the decimal window, so I'm going to zoom it decimal. There you go. Zoom decimal. Because if I trace, I get nice numbers. I've set it up for the pixels. I don't know why it's tracing on that, but it's there. Now, should we zoom in on it? It's nicer on the Inspire. It's easier. But zoom, and I want to zoom in, and I want to zoom in at 0. So I'm going to tell it 0. No, I'm not. Okay, trace. Put it at 0. Enter. Now we're going to zoom in. Zoom. This is what you were supposed to do in your lab. Enter. There's a nice curve. And so we're going to zoom in again. Zoom, and you go, let's press enter. There it is. Let's press enter. You guys should know how to do this. You did it in your lab. Okay, so we're going to do it again. I'm at 0. I'm going to make sure I'm at 0. Trace at 0. Looks like I am. Zoom. 2 is zoom in. Then you have to press enter. Am I getting that to look like a straight line? No. Let's do it one more time. Zoom. Okay, I'm getting a horizontal line on the left, but I'm certainly not, as I zoom in, not getting that to be a nice straight line. So it's not differentiable there. It says show that the following function has a left hand and a right hand derivative, but no derivative there. In other words, it means it's not differentiable. The derivative does not exist there. Okay, they want us to find the derivative coming in from the left side and coming in from the right side. Well, I'm going to be lazy, and even I want you to be lazy also. When you see lines, do this the easy way. Because what is the derivative? It's the slope. What's the slope here? It's 2. Now, you could do the f of c notation. You could do all that, but that's, to me, a waste of time. But let's do the x squared. I mean, I know what it is. I know what it's going to be. But you know what? We're going to make it even easier. It's the limit as h goes to 0. And what's my c value? I'm trying to find the derivative at where? At 0, right? So it's 0 plus h. No, minus f of 0. So I'm going to actually put the value in because I only want to look at it at 0. Okay, so it's the limit as h goes to 0. Well, f of 0 plus h is 0 plus h squared minus f of 0 is 0 squared all over h. Well, that's not hard, right? What's this one going to give me? It's just going to give you h squared, right? And that's 0 over h. Can I reduce that? You're right, I get 0 over 0, but there's a hole at 0. So this is the limit as h goes to 0 of h. So the value is 0. So the slope on the left here is equal to 0. The slope on the right is 2. Guess what? They're not equal. So there's no derivative there. Remember? These are limits. The limit from the left has to equal the limit from the right. The limit from the right is 2. They're not equal. Not equal to 2. This is the limit on the left. Remember how many times I've said that? Does not equal the limit on the right. Now, they could ask you that on the AP exam. They haven't in many, many years. That doesn't mean it's not fair game. It just means I haven't seen it. Okay? Oh, probably not till next week. I have to grade them. I don't know. We have to talk about it as a team. Okay. Let's answer the last question. It says, does a function have to be continuous at a point to be differentiable? Now, differentiable, you have to know that word because it's going to be on the exam. That's a guarantee. And that means you can find a derivative. The derivative exists. So if you have a continuous function, if you have a function, does it have to be continuous to find a derivative? So if I had this function right here with a little break in my graph, can I find the derivative at that c value? No, doesn't even make sense, does it? The point doesn't exist. How can you find a derivative, a slope, at a point that does not exist? So the answer to that question is, does a function have to be continuous to be differentiable? Yes. But what about the reverse? What if you have a continuous function and does it have to be differentiable? Give me an example. One we just did, or a nice easy one, absolute value. If you zoom in on this corner here, you keep getting a corner because the slope here on the left is -1. The slope here on the right is +1. They're never going to be equal. They have to be smooth to be differentiable. So the answer to that question is, must it also be differentiable at that point? No. Now, one last thing. What information do you get if you were told that the function's differentiable? Do you have to have a continuous function? Yes. So the symbol for implies is this little symbol like that. That means implies. So they're going to tell you that you have a function that is differentiable. And when you know that, you now know that f of x is continuous. That's huge. They're not going to tell you have a continuous function. They're going to say it's differentiable. So what does it mean for something to be continuous? Remember the three parts? F of c must exist, right? Now, you might have to show that you have a differentiable function. You have to show that the function's continuous first. And then what's true about the limit? As x approaches c of f of x is what? Must exist. And last but not least, that's not enough. What has to be true about those two values? They must, and that's an equation. That's an equation. Equals f of c. Sometimes you have to make that equation and you have to solve it. Okay? So now we have questions on homework. We have about 15 minutes. Either I can do homework, some homework problems with you, or I can let you work. 33. In fact, in particular, I should do.
What's our specific homework for today?
It's on your it's on your calendar, and it's also on your assignment sheet. I also want to do 57. Now, if you want some of the other problems, because I didn't do 33 in the other class, it's fine. It's on their smart board. They're the purple sheets over there. Otherwise, if you wait till after class, I'll get it for you. The calendar is on Schoology. It's just an assignment sheet. Now, we did a lot of the fraction problems. Now, if you haven't done this, you should take your assignment out, girls, and write it down. And with this, you're writing your assignment. And it asks me on 33, 17, you could throw 17 out because it's kind of silly. Look at it and tell me why it's silly. If you can't tell me it's silly, then you better do it. No, this is page 135. Okay, so we are looking at 33, and it says, find the derivative and write the equation of the tangent line. And also, if you read the directions, sometimes it has little things in the directions that explain to you exactly what you're doing, which I really like about this book. So what form do you want to use? Do you want to use the C plus H form or the other one? Let me write them both down. So it's f of c plus h minus f of c all over h. In fact, did they tell us which formula? I think they do on this. No, they don't tell us that. There's another form. It's this one. And it's f of x, whoops, it's not h, over x minus a, and x is approaching a. Honestly, I think the second form's easier to do on this problem than the first. But I don't care. I'll do it either way. You want to do the second one? Okay, so it's the limit as x approaches a, And so I'm going to put in f of x, so it's 2x plus 1, square root of that, sorry, minus f of a, which is the square root of 2 times 4 plus 1, all over x minus 4. When I clean this up, should look familiar. It's the square root of 2x plus 1. What's that going to give me? Minus what? 3 over x minus 4. Except I forgot to put my a in here. My a is what? 4, right? Okay. If you put in 4, what do you get? You should get this. You should get 0 over 0, right? Now, do you remember how to deal with the radicals? What am I going to multiply by? So I did the fractions in the other class, but I don't have a video of that. But it's the square root of 2x plus 1. It's a trick. And then what do? Plus 3. And then I have to do the same thing in the denominator, but we're not going to multiply that out in the denominator because I want it factored. But in the numerator, I do want to multiply it. So we're going to multiply it. I chose it this way. It's rationalizing the numerator. I chose it this way so I get the radicals out of there. So what am I going to be left with? 2x plus 1. What happens to the middle terms? Multiply these guys together. Sorry, I should have had 2 there. I miscopied. I would lose a point. First of all, I would change the problem. That's one problem. Okay, so I get 2x plus 1 here, right? What happens to the middle ones? They go away. And the last ones are minus 9. Okay, we should be able to multiply those out fairly quickly. These I'm not going to multiply out. It's not quick anyway. So it's x minus 4 over the square root of 2x plus 1 plus 3. And then I can't think of anything to do but to simplify that numerator. It's not that bad. What's that going to give us? The limit as x approaches 4, it's 2x, what? 1 plus 1 minus 9 is minus 8. You still have the 0 over 0. Some of you should be seeing what factor it is. It's going to cancel. That's where your zeros are. Remember, when you get 0 over 0, you have a whole. So this is the limit as x goes to 4. And I'm going to factor out what? 2. And I'm left with x minus 4. And guess what? I have an x minus 4 in the denominator. And it's the square root of 2x plus 1 plus 3. Can I reduce that? Yeah. I can get rid of the x minus 4s, can't I? So that goes with this one. It's not x with x and 4 with 4. It's the whole thing. So now I'm left with the limit as x approaches 4 of 2 over this thing plus 3. Okay, so what am I going to get? Hey, guys in the back, what do I get? I get 2 over 4. 2 times 4 is 8 plus 1, so that's 9. So it's 3 plus 3. So it's 2/6 or. Now, did they ask us for the equation of the tangent line? Notice how long it takes to do some of these problems. They do. So if you haven't started, you have a big math night tonight. That's good if you're done. I want to do one more, but let's see. I want the equation of the line at this point. I'm going to use point slope. And point slope, if x is equal to 4, what's the y value? Y equals 3. Right? We've been doing that several times today. So it's y minus 3 equals my slope, and it's x minus 4. What was my slope? I forgot it already. 1/3. And you're done. You don't have to do any more with it. Now, I don't know what the answers look like in the back. You need to know this 100% because you will be writing equations of lines several times on that exam. So if you can't do that, and there are students that take the exam that can't, that's a problem. I evaluated my function at 4. So f of 4 is equal to the square root of 2 times 4 plus 1. So that's 9, right? Okay, I want to also look at, turn the page, 57, so you understand what's happening with 57. Okay, that's not what I want. I want this. I don't know why that does that. It'll work. Okay, it's just weird. 57, and Mrs. Hirschman says 57 through 61 are important questions. Yes, they are, because you are not going to do this by hand on the exam. You're going to see a problem like 57, and you're going to recognize it. It's the limit as x approaches 2 of 1 over x plus 1 minus 1/3 over x minus 2. So you do need to know both forms of the derivative. Okay, girls?
Yep.
Which form does that look like? First one or the second one? Looks like the second one. So what I'm going to do is write that in. Sophie? This is x minus a. This is how I do it. And this is f of x. And this is minus f of a. It looks like that, because I don't even have an h in there. I don't have a 0 or anything. And then this is x approaching a. Well, what's a equal to? 2. It's pretty easy. I like this form better. What's f of x? Right here. 1 over x plus 1. So on the exam, you're going to see a problem like this, and you're not going to calculate that limit. You're going to say, oh, it's this function, and I'm going to end up doing my rules, which we haven't done yet, for derivatives, and I'll be done with it faster. And honestly, I'm not sure that that's true. I might be faster with the fractions, but usually it's something simple. Then they do ask you to find that limit, so I think we should do that. Okay, so I'm going to rewrite it down here so I have some space to work, maybe. And this is one of those ones with fractions in it. So it's the limit as x approaches 2. It's 1 over x plus 1. If you put 2 in there, that's where the 1/3 comes from. Problem 23 is similar. And this was x minus 2. Just want to make sure I copied it right. Okay, how do we get rid of fractions? Do you remember that?
Do x plus 1 times the...
Yeah, multiply by all the denominators. This one's 1. This one and this one. It's 3 times x plus 1. And then the other 3 times x plus 1 is in the denominator of the big fraction, not the little ones. And you should be doing this with me. Oh, am I going too slow? Okay. What happens when I multiply? Now, if you want me to show that, multiply it out. But I picked it this way. The x plus 1s had better go away, and I'm left with a 3. Minus, be careful, the 3's go. What's left? X plus 1. This one's going to be tricky. You'll see why in a second. It will be on the reducing. Okay. Now, I can't think of anything to do but to simplify that numerator. You can't cancel because these are add-ins. They're separated by minus signs, which is an addition sign. Just the opposite of it, that's all. So I'm going to go ahead and simplify that. That's 3 minus x minus 1 or plus 1? Minus 1. If you don't put the parentheses in, for sure you're probably going to get it wrong. Remember, you had 0 over 0. So if you simplify it and you don't get 0 over 0, then you know something's not right. You know you made an algebra mistake. Okay, so this is 2 minus x over x minus 2 times 3 times x plus 1. Now, the 2 minus x and x minus 2 are not identical, but they do cancel out, but what do you get when they cancel? You get negative 1. Good, that's the tricky part. To me, it's the tricky part. Because they're opposites. So I'm going to get negative 1 over 3 times x plus 1, but what's x? X is 2, so I'll put a 2 in there. So it's negative 1 over 3 times 3, or negative 1/9. And we could check it with the calculator. Now, did they ask for the equation, or did they ask for, no, they just said find the slope. So if you want to use the calculator to graph that, we can. Let's just review that real quickly. I'm going to bring up my smart view, maybe. And I'm going to put that function in. So in y equals, I'm going to put 1 over, so I'm going to clear that out, clear this out. 1 divided by 1 plus x, or x plus 1. Now I'm going to zoom it decimal. Okay. Okay, guys, I want the slope at 2, right? Do you remember how to do that? You go second, calc, 6. That's the slope. Just think of a delta y or delta x, dy dx, same thing. It is. And then you just type in 2. And there it is. It's negative 1/9. You note that as a repeating decimal. So